Hi everyone, I'm Francesco Penta and I'm a Principal Cloud Support Engineer at AWS and I'm based out of Dublin, Ireland. Welcome to AWS Supports You, where AWS Supports experts provide tips to optimize performance in the cloud, lower cost, and provide you with the best practices and design consideration. Joining me today is Milan and Tipu from AWS Support. Can you give us a quick introduction, Milan and Tipu?
Hi, everybody. My name is Milan. I'm a support engineer based in Dallas, Texas. Nice to be here with you and answering all questions today.
And I'm Tipu. I'm an engineer based in Seattle. I've been working with the customers and moving workloads and operating on them. Over to you, Francesco.
Glad to have you here today. So today we'll be answering some questions from repost and we'll be going to focus on the security, identity, and compliance section. But before we get into the details, a quick note to the attendee online. So feel free to use the chat window on the right-hand side of your screen to let us know where you're joining us from today and share your thoughts and questions throughout the episode. We look forward to hearing from you. We'll also provide a link to our survey. So if you'd like to let us know how we did, please click the link and leave your feedback if you have any suggestions or any other episode that you would like to see. And with that said, Milan, can you walk us through what we're going to be talking about today?
Thanks, Francesco. So today's agenda is going to be, we're going to be reviewing some of the security-related questions that the customers have asked us on AWS repost. So the first question of the day is going to be how to get an STS regional endpoint in a real scenario. And this is one of the questions that one of our customers has asked and was curious how to get the regional endpoint using a Python SDK. But before we get to the answer, we're going to put some leveling in terms of what the AWS STS is. So AWS Security Token Service, or AWS STS, is a service that vends temporary security credentials, and it's actually one of the oldest services. It represents the base for many use cases that you're used today, such as roles and federation, the instance profiles and roles and like other stuff. So as I said, it's a basis of a temporary security credentials. But before we go there, we need to kind of understand what the temporary security credentials are. And when we think about credentials, right, you have your standard long-term credentials in form of the access key and secret access key. When you create an IAM user, you would put that into your configuration of an SDK or your CLI, and then you would use those long-term credentials, right? But you have to think about all the nuances that come with the long-term credentials. Now we have to securely store them. We need to make sure they're properly rotated, and tend to all the best security practices, right? And this is where the security token service, or AWS STS, comes into play, where it vends the temporary security credentials, which are by nature very short-term credentials. They can be configured to last from minutes to a couple of hours, right? And after the credentials expire, they're no longer valid. So you don't have to think about proper rotation strategies, right? Or long-term storage. Because they are short-term, they are dynamically generated, so there's no need to provide any additional context around them. So once they expire, they are gone, and AWS no longer recognizes them. However, the users can request and use temporary security credentials before they expire, so that way they can rotate and have a fresh set of credentials not to interrupt their work. And once they're done with those, the credentials will just expire on their own. It's a very niche approach, right, where you do not have to embed the long-term credentials, right? You can use the short-term credentials. And the common scenarios are, the identity federation, right? So when we talk about identity federation, it's, we can manage our users and their identities in an external system. And then rather than creating AWS identities for them, we can set up the identity federation. And for example, in an enterprise environment using the, single sign-on or the a security assertion markup language, or SAML, we can manage our users outside and then use AWS SSO or Active Directory, and that will allow us to avoid creating users. We can just map them to roles, right? And you'll notice that the roles are also here as an example. They are a basis also. The STS is a basis of roles for cross-account access. So we will want to give, for example, access to, we have multiple accounts, like most of our customers today have multiple accounts where they, manage access through the IAM roles. And, granting permission, or somebody granting permission to access a resource in a different account can be done through, roles that allow cross-account access. And so this is where, again, STS is a service that's powering this. Also roles for Amazon EC2 instances. So in case you have applications running on EC2, you can grant security credentials to those instances, or IAM credentials to those instances by using the roles for EC2, and this is abstracted fully away, so you don't have to manage this. And behind the scenes, there are also temporary credentials, and many other AWS services. Pretty much, anything that touches IAM, right, is using the AWS STS when it comes to temporary credentials. Now, when we talk about the endpoints, the AWS STS is available in different flavors, where there's a global endpoint, which is available by default, and it routes all the requests to a single endpoint, which is STS Amazon.aws.com. Now, the tokens that are vended by this endpoint by default are something that are called version 1 tokens. And these are valid tokens, but only for a certain set of AWS regions. With introduction with the regional endpoints, the token version has changed, and now the regional endpoints actually have something that's called the version 2 token. And the difference is where these tokens can be used. And I'll talk a little bit more about it in a bit. So when we think about the regional endpoints are closely, they're in that region. You can use the regional endpoints to reduce the latency, right? By making a call to a regional STS endpoint. It's closer to your services and your applications, and you can access the other AWS services much faster, right? Because you're not spending that network time for STS to go to a global endpoint and then get a response back. You can also build in redundancy, right? If by whatever is the reason where you can code your application logic to switches the STS calls from one region to another, or maybe even go to a global one as a fallback, right? This ensures that, like, for example, if a region stops responding from whatever the reason is, your application can continue operating and getting the temporary security credentials. The caveat here is that the redundancy is not built into the SDK, so this is something that you will have to build in your own fashion, tailored to your own use case. The session token validity. As I mentioned earlier, the global endpoints vend tokens which are only available in certain set of AWS regions. And those are regions basically which are enabled by default. So when you request a token from a global endpoint, you cannot use that token, for example, in the Asia Pacific, Hong Kong region. You can only use those tokens in, like, for example, North Virginia. That said, when you use the regional tokens, those tokens are valid in all the AWS regions. You can also change the global endpoint configuration to vend the tokens which are available in all the regions. However, you have to be cognizant that the tokens are a little bit larger, and the version 2 tokens are larger in terms of the payload than the token version 1. So in case you're storing it, for example, building a solution, which is a token vending service, right? You have to be cognizant that there are certain changes, right? And this is, we're going to see that right in a bit. Why is that important? So regional endpoints are available at HTTPS, STS, and then AWS region.amazonaws.com. In this particular example, we have a regional endpoint for US West Oregon, US West 2 on screen. And then, we go back to the question, now that we have certain basis on how STS works. And on screen, we have Python code. So this is an example of the AWS Python SDK, also known as Boto 3. And in a very small example, in the first line, we're importing the library. Then we're instantiating a client in the second line with sts_client equals boto3.client. And then the first argument is the service name. And our Python SDK provides metadata attributes that you can use to inspect certain elements of how the client is configured. And in this case, we're using a metadata attribute called endpoint URL, which will tell us, hey, what is the SDK going to use? As you can see, in this particular example, it's going to default to a global endpoint because I've not provided a region, or I've just instructed the client to do what it's supposed to do. Behind the scenes, it's loading the environment variables, but still, you can see that it defaults to the specific region. Now, if we look into, for example, a more specific case, and I say, well, I want to use, say, US West 2, right, to go back to our previous example and use a regional endpoint. In case of like an EC2 client, so here we have an example similar, right? But when we use an EC2 client, we instantiate it, and we pass a region name parameter equals to US West 2. If we look at the metadata attribute for that client, we're going to see that it actually uses a regional endpoint, right? It actually tries to use ec2.eus-amazon.aws.com. However, if we do the same thing for STS client, and we look into the attributes again, we're still going to see that even though we pass the region, it is still defaulting to the global endpoint. And this is by design, as I mentioned earlier, due to the different versions of the tokens. The SDKs inherently implement something that's called a legacy default behavior, which I'm going to touch in a bit, right? So how do we knowing what we know now, how can we actually access the regional endpoint? So there are a couple of ways to configure your client to access a regional endpoint. The first one is the using of the environmental variable, which is presented on the screen, AWS underscore STS underscore regional underscore endpoints. And then the values for those are legacy or regional. The difference is when we use a legacy variable value, it is going to default to a global endpoint in the regions which are enabled by default. And for newer regions, it will actually default to regional configuration. Now, the catch-22 there is that it's a little bit of inconsistency. So, we want to have consistency, so we want to ensure certain behavior of our SDKs. So that's one way where we can do this. Another way is using a Python SDK config file or a config object. So, and it's a very similar thing. Like you can configure the STS underscore regional underscore endpoints in either the Botocore config object, which is the low-level library that SDK uses, or in the AWS config file for your profile. And the third option is, we can manually, because we know how this thing looks like what is the endpoint URL, we can manually construct it and build, a wrapper client, for example, where, every time we instantiate an STS, we're going to pass a region and then we're going to formulate the endpoint URL. Because if you remember the example, the customer has actually tried to use that endpoint URL. So when we look into the regional endpoint, so the difference here is the first half of the example is pretty much the same, right? We are instantiating a client. We're trying to use US West 2 as a region, right? And we're looking at the metadata attributes. Nothing's changing. And then by implementing the environment variable, we said that, hey, we want to use the regional endpoints. And when we reinitialize the STS client and again look into their endpoint URL metadata, we're going to see that it's actually now using a regional endpoint. So this is the way that you can implement your SDK behavior, influence the SDK behavior to use the regional endpoints. And this is standard across multiple SDKs. There's a caveat in certain newer major versions of SDKs will use the regional endpoints going forward. So for example, AWS CLI version 2 actually uses regional endpoint configuration behind the scenes in version 2. In version 1, it's still using the legacy one.
Thank you, Ilan. So I have one quick question that I wanted to ask to clarify. You mentioned that this is one of the most common way of authenticating using EC2 roles, and wondering if you could explain a bit how that works. So if I'm going to use an EC2 role, how can I use those credentials, those temporary credentials, to authenticate with other AWS services from an instance?
Thank you, Francesco, for asking that question. So when you use EC2 roles, the temporary security credentials are actually made available through what is called an instance metadata service, right? That every single instance has an access to in AWS. So you can use this instance metadata service by querying a specific URL, like security, and then IAM security, and then the name of the role, for example. What you will get back is the response, which contains a secret key, secret access key, and session token. And this is all managed behind the scenes, so you don't have to do anything, right? The important bit there is to be cognizant that if you're using AWS SDKs for different programming languages have this behavior built in, so where they will actually look up through certain steps of how to enumerate and find the configuration for the credentials, like looking into the file, looking into the environmental variables, config file. Ultimately, it's also going to touch the instance metadata service to discover whether it's, are there any credentials available there. So in case you're using an SDK that's provided by AWS, you don't have to do any additional implementation. However, if you are using a custom application, using your own SDK or your own code, you can use the instance metadata service to query it and obtain the temporary security credentials. You can refresh these periodically. You can just create an object again, request the data, and once the credentials are refreshed, you can just use the new ones as well.
Perfect, thank you. And I posted a couple of links to the EC2 metadata service if you wanted to get more information about these. And specifically for the Java SDK, the order on which retrieves credential whenever there are credentials available on EC2. And this works similarly for other SDKs as well. You can look at that documentation if you need additional information. Thank you very much. Okay, so see that there's no other questions. I would like to bring on Tipu for our next question and let you introduce what was being asked. Thank you.
Fantastic. Thank you, Francesco. Thank you, Milan. Great question so far, by the way. So one question we've seen on Repost is how one can figure out how an SCP or just any IAM construct around a policy is denying access to a resource. And picking on the specific one for session control policies that are a control mechanism for AWS organizations, let's take a look at the landscape. Okay, so the first thing is, why does one even get denied, right? It's not always a matter of misconfiguration. Sometimes there is actually a good reason why people get denied access. It's because as a security best practice, we want to grant users and systems the narrowest set of privileges to complete the required tasks. This is what we call the principle of least privilege. So there are lots of legitimate situations where someone might not get access and get denied. But of course, there are some situations where it was just done due to a configuration issue, right? And we want to explain how all of this works so that you don't face this problem when it's unintended. So taking a step back, AWS Identity and Access Management has policies. So who can access what? The who is the principal. So policies get attached to principals, and the what is defined within policies. Policies get attached to resources. And in these situations, we allow certain people, the principals, to access certain resources with certain permissions here. As you can see in this example, we have the effect of allow to a certain principal for a certain action for a certain resource under a certain condition. So that's IAM as a whole. And then we heard from customers that management across multiple accounts at the organization level is really important. So AWS organizations really solve the problem of central governance. It allows you to define organizational units, have accounts be part of them, and then define the control, access, and permissions, as well as other policies. And so that's where these session control, these service control policies or SCPs really help. And these set of tools together allow you to audit, monitor, and secure your environment on the multi-account or organization level, as well as the general billing benefits that go without saying. Now, these SCPs are actually guardrails. So what I mean by that is that they're not necessarily there to explicitly grant permission. They're there as protective mechanisms. For example, you might not want to grant everyone access in your whole organization, the ability to create IAM users or change the organization itself, right? You want to restrict that perhaps to a very specific select set of security authorized people. And these guardrails set by the SCPs allow you to do that. So there's a preventative guardrail that comes through the form of this SCP, and then with the OUs, it gets applied to the accounts. Right, and that way you can make sure you're compliant. The SCPs ensure that, and there are other services such as AWS Config that further help you to ensure that if something was misconfigured, you can be alerted, or that some automated action can be taken as part of the guardrails. So once again, guardrails are preventative. They prevent policy violations using SCP. But the key part here is that the SCPs, they don't replace associating IAM policies with an AWS account. You still have to apply the IAM policy on a principal for a certain resource, as we discussed in the previous slide. All right, so what can go wrong here? Now, as I explained, there are guardrails. Organizational SCPs are one. You have other tag-based policies, backup policies, permission boundaries, and all of these things prevent unintended access to be given so that we can stick with our security best practice of principle of least privilege. However, in order for someone to get permission to do something, for the principal to do in effect, we have to do grants, right? And grants come in the form of identity-based policies, resource-based policies, and object ACLs. And now, in order for a user to be able to, or for any principal to be able to take an action, take an effect, they must, one, not go against the guardrail and also have a grant. So here are just some steps that you can take to figure out what's going on. And after this, I will go over some tools that can help make this easier. But first thing is check in CloudTrail to confirm the error and the principal. And I say this because the CloudTrail message can give you some great hints into what's going on, why it's being denied. Because the deny error message can sometimes tell you exactly why it's being denied. And so those CloudTrail events in those logs are very useful. Next, check if an IAM policy with the right grants, the explicit allows, are attached to the IAM user or role who is expected to have this permission. And then, as you can see in this example at the bottom, this is an IAM policy which has the effect allow of EC2 describe instances and EC2 describe images. So this is, I'm explicitly allowing, using this policy, any person to run, so the specific person I'm going to attach this policy to describe instances or describe images on any resource. So why could access still be denied even though I've attached a policy that is doing the explicit allow? This is where those guardrails come in. And first, check if the policy statements that grant those permissions include any conditions, such as time of day, IP restriction, time of day or IP restriction. So the policies are granular enough that they can restrict specific IPs or even only allow access for a certain time of days. So those sort of restrictions are things you should check for in the policies. And then lastly, SCPs, which are taking effect on the organization level, you have to ensure that they're not denying a broad set of actions that could be causing this unintended permission denied, because the deny will always trump allows. And so as you can see in this example over here, there is a deny on all IAM and RDS actions. So if the permission that you intended for an IAM role or user was to do some RDS operation, this SCP guardrail would need to be changed, right, to ensure that the person can do it. Now, here are some tools that can make it a little bit easier for you. The first is IAM Policy Simulator. The benefit of this tool is it allows you to put in the policy and then see why it gets denied. Really understand the reason for it, so that then you can correct the policy before it actually takes any impact in a production system. So I recommend using this as part of your troubleshooting process. Another useful tool is IAM Access Analyzer, as it reviews CloudTrail to actually create policies. And so if there were CloudTrail messages showing that there's some user who's doing some action, it can actually recommend policies based on those actual CloudTrail API logs, which are useful. And it generates fine-grained control policy permissions, similar to what we talked about, the principle of least privilege, and then also gives you recommendations. So let's see what this looks like. In the screenshot, you can see that there are certain policies that are applied, and then there are recommendations that are given. So there's a security recommendation that's given there through a IAM access policy validation, so that you can have the best policy adhering to the right best practices and ensure that you have better security posture. And that's it. Francesco?
Perfect. Thank you very much, Tipu. And before we go to the next question, I wanted you to clarify a bit one aspect of this. So definitely very useful tools to use, but I would like to understand a bit more how do permission boundaries, IAM policies, and service control policies work together. So they seems to be quite similar in terms of what they do, but can you clarify a bit what their permission boundary and how they work?
Absolutely. So identity-based permissions or things like IAM policies that you've attached to a user define how a user can actually take effect on a specific resource. And there has to be sort of this intersection between these permissions. So I'm really glad you brought up permission boundaries as well, because permission boundaries are also sort of this guardrail that prevent permissions from being implemented that were unintended. So SCPs is across the the organization level. It controls that. So you must have no deny in the SCP policy. the permission boundary must also not deny any of those permissions, and the IAM policy must also explicitly give those permissions. The intersections of those is what the effective permissions for the person or for the action are.
Perfect, thanks. And I've seen we use those two tools quite often with our customers to ensure that they were able to pinpoint. Sometimes it might be a bit tricky because you have an explicit deny or you forgot the allow, and then you go in implicit deny, and it has helped quite a bit. So I recommend if everyone is having issues, as Tipu suggested, CloudTrail first, and then you can use those two tools to dig in a bit more next. Thank you, Tipu. I hope everyone found the answer to this question super useful, as I did. So going next, I would like to answer this question. So one of the user asked how they can increase the performance of fetching secrets using AWS Secrets Manager. And the question revolved basically around figuring out how they could improve the speed, because they saw a latency of on average of 200 milliseconds when retrieving secrets from Secrets Manager. And if you're using VPC endpoints, will help a bit more with the speed, because anytime they're caching, they have the issue of caching stale credentials every now and then, would obviously cause application issues. So basically, I wanted to answer this by saying that VPC endpoints are not the solution to faster retrieval, and we'll see that in a second. The VPC endpoints are really meant to be used anytime your application it needs to be in a private subnet, or you want to keep those resources in a secure, non-internet accessible subnet. You can create a VPC endpoint that will allow that application, or your Lambda function in this case, to access AWS Secrets Manager without having to use an internet gateway or a NAT gateway. So basically keeping those resources in a secure private subnet. When we're using an internet gateway, we're still going over the internet, staying in region. Hopefully you're using the Secrets Manager in the same region you're running your resources to reduce latency. But the path is taken will be pretty similar, and you will be having a connection latency of around 1 millisecond. And depending on which IZs you're calling from, but hopefully and will stay around, it will stay around 1 millisecond. The latency that the customer is seeing is definitely comes from the time it takes to retrieve the secrets, because there are several checks and mechanisms that happens behind the scenes when retrieving that secret. So the first thing is that a lot of our customers using, wanted to give a bit of context into secrets managers and how this is used, because one of the main advantages in using secrets managers to manage your secrets is the ability of rotating secrets safely. So this means that you can change your secrets so that you can transform a long-term secret, something that's immutable, into a short-term secret, so something that changes every few hours, every few days or weeks, depending really what is your security requirement. This means that in the case your credentials are unfortunately compromised, or that you need to revoke those credentials for whatever reason, you are not impacting all your applications. You're only impacting that secret that is now being rotated and is getting invalidated pretty soon. So this is one of the best security best practices. Works similarly to the concept that we have with the STS and temporary credentials, and allow you to have a more robust and application. Secrets Manager is built with RDS, is extendable with Lambda when you have to rotate credentials. It is something that allows you to basically create your own rotation strategy as well, and allows to use versioning as well, so that you can ensure that you don't break secrets that are rotated. What this means is that it is important to cache, and it is something that you can work around the issue that our users saw in this question by using proper rotation strategy. So let's see why caching is important, first of all. So this is a recommendation that we make wholeheartedly. We recommend to cache your credential using client-side caching, and this is because it gives you a couple of benefits. First of all, improves the speed. Since you do not have to contact a secrets manager to retrieve your credentials, the retrieval of cache credentials, since it's staying in your Lambda environment or your caching system, whatever you're using on your application, is almost immediate, which is lowering the time it takes. So this gives a better customer experience. You'll also be making fewer API calls to retrieve those secrets, and those API calls have a cost around 5 cents for 10,000 API calls. Obviously, this might not be impacting you if you have low volumes, but when you're having thousands and thousands and hundreds of thousands of calls per day, that might add up. So caching will reduce greatly that cost. Additionally, if as our user you're using Lambda, then that also reduces the Lambda execution time. And depending on the size of the Lambda that you're using, that might add, and the number of concurrency that you're having and invocation that you're having for that Lambda, that might add up to pretty sensible savings when you're reducing that time. So the second thing that I wanted to say is that if caching is fundamental, how we can avoid issues where you're caching stale credentials. This means that anytime you're caching, you might be holding something that's no longer current. So the first consideration to make is that you want to cache those credentials for a shorter amount than you're rotating those credentials. So we're rotating credentials every 8 hours. The TTL on your cache should be lower than that. That ensures that anytime we're retrieving credentials, we're not caching for longer than the actual credential lifetime. The second thing that we can do is that if the secret is invalid, so let's say that we are now caching stale credentials and we attempt to connect to our database or our application, we might want to retry with the second attempt by retrieving the secrets from Secrets Manager directly. So basically having a fallback to retrieve fresher credentials. The third thing is that depending on the application that you're using, and this is usable for RDS, for example, you might want to consider using a different rotation strategy, because so far we are only discussed about rotation strategies where anytime you're rotating credentials, then you are invalidating the current credentials, which means that if you're caching those credentials, they are made invalid and creating problems whenever you're trying to access something. When you're caching, you don't have to do this on your own. There's a few tools that are built in, especially when using Lambda. There's a couple of blog posts. I'm going to post those links in the chat now for either using Lambda extensions or a nice blog post on how to securely retrieve credentials that teach you how to use those caching mechanisms to ensure that your credentials are retrieved and are always fresh for your environment and basically not having to build that on your own. But even if you're not using a Lambda and you're deploying these on your EKS cluster or your own classic application, you can use the built-in libraries that the secrets managers offer for Java, Python, .NET, and Go. There's a link to the generic section where you can go and look a bit more in those libraries, but these allow you to cache credentials as well, allowing you to follow best practices. Now, we mentioned the rotation strategies. This is basically means how you're rotating your credentials. Normally what everyone uses more often than not is a single user rotation strategy, where you have a single user either in your database or your application, and anytime you're rotating the credential, you're creating new credentials and invalidating the old ones, which might lead to the problem that you're having, because if you're caching, then that will then bring, we'll try to use invalid credentials since we have just rotated those. What we can actually do here is to use what we call alternating user rotation strategy. What this means is that we'll have two sets of credentials for a single user. And then anytime we're rotating the credential, instead of immediately invalidating the current credential, we're versioning them and we're bringing them to a state where they are not disabled, but they are going to be scheduled for disabling on the next run, third run, basically. So at this point, you will have a current set of credentials that are valid, a slightly older set of credentials that will still be valid. And then when you're doing the third rotation or the fourth and so on, you will always going to expire the older set of credentials. To explain this a bit more clearly, draw this graph where we have your secrets manager with your database secret, your RDS database in your VPC, and an application that's attempting to connect. So normally what happens is that your application contacts a secrets manager by retrieving credentials. And those credentials, so it issues the call from the application to secrets manager, and the secrets manager responds with a set of credentials. For simplicity, we'll call them UA and PA, so where will be username and password. The application will have those credentials and then send those to the RDS VPC in the VPC by sending the credentials. And if everything works well, as we see, we do have the user, will return the data from the database. Now, what happens is that when we're going to rotate credential, or the Lambda, our rotation function, is going to create a new set of credential in our secrets manager by versioning them, and let's call them PB and UB and PB. What happens now is that the Lambda will also be responsible for creating the user in the RDS database and then validating that the user that just created can access the data that we require. So basically, we'll have a second call that attempts to validate the call. And if everything goes well, then is when we will have the rotation. So when we have the rotation, what happens is that instead of invalidating credential, we're simply swapping the versioning labels. So the next time the application is retrieving the credential from Secrets Manager, is going to retrieve the current version, which will be the new credentials that we have created. We'll attempt to connect to MySQL in the VPC. And obviously, since the username has been created, it will be able to connect and retrieve the data. What this means is that when see if we still have cached credentials from the previous attempt, let's say that we just got credentials, they're about to expire, those credentials are still valid. So if we play safely with the TTL, we'll end up in a situation where the credentials are never expired. At least we cannot have a situation where caching is stale, and allowing us to always be able to connect to the database. And this does not only work for the database. Obviously, this is a strategy that you can implement for your own application or for using credentials that allow you to access any other system. That this is something that is built in RDS. So the RDS rotation strategies and Lambda that are in GitHub, I'll post a link to those, have a built-in rotation strategy for alternating users as well. But you can see from that code how that can be used, and now the validation can be done so that if you want to port this to your application, you can do that as well. That said, hopefully that answered that question. And I wanted to bring Milan and Tipu, see if there was any question from the audience at the moment.
So I have a question. You mentioned earlier that we should be looking at a smaller TTL and like playing around with it. Can you elaborate a little bit more and expand? Why is it important, and what would be like recommend? Should we go fast, like with a very small TTL, or maybe a longer one? Like what do you recommend to our customers when you're working with them on this topic?
Perfect. Thank you, Milan, for the question. So obviously TTL needs to be smaller than your rotation time, because if you're rotating every 8 hours and you have a 10-hour TTL, you will end up in a situation where you will have stale credential for at least 2 hours. And obviously we want to have this to be shorter. The other issue that we have is that we might end up in a situation where we're starting with a cold Lambda just a couple of minutes before the credentials are rotated. So even if we have 6-hour TTL for our cache, we are going to rotate credentials in 2 minutes, which will give us invalid credentials for 5 hours and 58 minutes. So that is obviously not really desirable. The shorter the TTL, the better the chances that this is not going to happen or the credentials are going to be refreshed, but you definitely want to get in a situation where you're caching for as much as possible. So if you have a strategy for invalidating the cache, so basically if you get an access denied, you go and attempt to get those questions from those credentials from the secrets manager, then you can do that as well. It will be a small performance hit and definitely depends on how you want to structure your application. If you're using the alternating user strategy, then the important thing is that your cache is smaller, your TTL is smaller than the sum of both of the rotations. So if you're rotating every 8 hours, it needs to be at least lower than the TTL of a single rotation, so that allows you to never exceed the validity of the old credential in case you're having a stale cache. But in the end, the rule of thumb is always shorter than your rotation, at least depending on a few hours if you can spare it. And then if you're using the alternating user strategy, still shorter than the expiration for a single rotation, and that will allow you to be able to connect and validate your credentials as much as possible, having stale credentials. Okay, Perfect. So hopefully that answered your question, Milan.
Thanks, Francesco.
Just wanted to thank you again for taking the time answering the questions, and just want to give a brief recap. We answered some questions regarding STS, the IAM control tower policies, and the SCP policies for organizations, and the best practice for KMS credential rotations. If there are any questions that were not answered today, or even if you get any other questions while you're rewatching this episode, you can post your questions on repost.aws, where one of our experts can provide you with an answer on your question. Could become a topic of one of our next future show. If you have any feedback for us, please check the chat box on the right side for a link to our survey, or you can email us at awsupportsyou@amazon.com. We want to hear from you. If you have any other idea or questions around the different episodes, we would like to know what you would like to see on this show. And also, please join us again next Monday on October the 3rd at 11 Pacific time, where we'll be exploring VMC and Cost Explorer. Again, I want to thank you for being with us, Tipo and Milan, and thank your audience for joining us at AWS Supports You, and happy cloud computing.
Thank you.